Hello everyone. Today we will start with a new unit, Unit 8. Unit 8, it's about electricity. First lesson, 8.1. 8.1, it's about electric charge. Electric charge, this topic you already studied in grade 9. When in grade 9 we studied about static electricity. So what do you mean by electric charge? Electric charge or electricity can come from batteries or generators. It's like from where we can get electric charge, it's either from batteries or generators. Or in addition to this, some materials, if you will rub these materials together, so what will happen? These materials will gain a charge. So they will have a charge. Some materials became charged when they are rubbed. This charge is sometimes called electrostatic charge, or they call it static electricity. This electricity or this electric charge, it causes sparks. Okay, it causes sparks when two objects are rubbed with each other, and also when they take off or pull over from each other. If we will take an example, this of course it happened to all of you. When you are sitting in a car, okay, then when you try to open the door of the car, so what will happen? A spark will happen. Okay, what's this? This is a static electricity. But how the form or from where it comes? It comes because two materials were rubbing on each other. What were these materials? The two materials were your clothes and the seat of the car. So here what is happening, two different materials, they are rubbing each other. So at the end what will happen? They will gain energy. So when they will gain energy, if you will if you will touch anything, then what will happen? This electric charge, it will be moved or troubled. So what will happen? It causes the spark. Negative and positive charges. When you will say electric charge, here you mean the charge, it's either will be positive or negative charge. Some materials or materials in general, when you rub them with each other, some materials will be positively charged while the others will be negatively charged. It depends on the features of the material. It depends on the characteristic of the material. For example, if we will take these two materials, polythene and perspex, can be charged by rubbing them with a dry woolen cloth. Here we have one material, or the first material, polythene. The second one is perspex, and we will rub these two materials with a cloth, woolen cloth. Now, after rubbing them together, what will happen? Now they will be charged. But how? When two charged polythene rods are brought close together, okay, here, look at this drawing or these diagrams. Here, as you can see, here we have polythene and perspex. See here what happened when you rub these materials with cloth, the polythene will be negatively charged while the perspex will be positively charged. Now, if you bring two polythene and you put them close to each other, what will happen? As you can see, the arrows, it shows they will move away from each other, or we will say they repel each other. While also here in perspex, also they are both of them they are positively charged. If you will put them close to each other, they will repel each other. But if you will take one polythene and one perspex, put them next to each other, we will see they will attract each other. Where charges come from? Firstly, to understand this part, this charge, it comes from where, we should understand the structure of matter. Okay, the structure of matter, or all the materials we said, are made up of atoms. These atoms, it consists of parts or subatomic particles. We call them the electrons and proton and neutron. Proton and neutron, both of them, they are attached to each other in a region we call it a nucleus. And the electrons are subatomic particles that are found outside the nucleus or are orbiting the nucleus. So the proton has positive charge, electron has negative charge, neutron has no charge. The normal or the neutral atom, before rubbing it, it consists of an equal number of electrons and protons. So, before rubbing it, what kind of electric charge it has, or what is the electric charge of it? You will say it has no charge. Why it has no charge? Because the number of electrons, it's equal to the number of protons. So if we will represent it as math, so let's take this example. Let's say you have three protons. What is the charge of proton? It's positive. Okay, the charge of it's positive. Now, and how many electrons? We said always it will be equal. So also we will have 3 electrons. What is the charge of electrons? It's negative. Now, can you find the answer? What is the total? Positive 3 minus 3. The answer will be 0. Okay, so 0, it means no charge. So at the beginning, before we rub the materials together, the atom, it is a neutral. What's that mean? It means it has no charge. But later, when you will rub these materials together, what will happen? These electrons, it will transfer, it will move from one material to the next one. So, when two materials are rubbed together, electrons may be transferred from one to the other. So now if you, let's say you have another atom, it's here. Firstly, both of them they have no charge because it's equal number of electrons and protons. But when you will rub them together, some of these electrons, it will transfer from one atom to another. Now here, let's say here we have 1, 2, 3, 4, 5, 6 electrons. If 6 electrons and 6 protons, now the total charge of it has no charge. Now, if we will take one of these electrons and give it for the next atom, what will happen to this atom? How it will be charged? Positive or negative? Stop the video, think about it, give the answer. Now, the answer. If this atom will lose one electron, now it means it will have 5 electrons and 6 protons. So now, how it will be charged? What kind of charge it will have? Of course, the charge will be positive. Why positive? Because now we'll have 6 protons and 5 electrons. So positive 6, negative 5. So the answer will be positive 1. Okay? So now it will be positively charged. When one material ends up with more electrons than the other, okay, when you rub them, these electrons will be transferred from one atom to other, from atom of first material to the atoms of the next material. Now at the end they will have an equal number of electrons and protons, and this what it gives the charge for the atom. Rubbing materials together does not make electric charge. It will not create electric charge. It will what? It just separate charge that are already there. Here, as you can see, here we have example of the polythene and perspex. How when you rub them with a cloth, so what will happen at the end will be charged. Why? What happened? If you will follow the arrow, you can see how the electrons are moving to different directions. Here it was from perspex to the wool, but here it's opposite. It's from wool to the polythene. Conductors and insulators. Conductors and insulators, the materials, all the materials are grouped into two main groups depending on their ability to conduct electricity. For example, now when we say it, if you rub two materials together, the electrons will transfer from one atom to another one. Okay, now we have a kind of materials, we call them conductors. What do you mean by conductors? We mean by conductors that are the materials that it let electrons pass through them. This is the definition for conductors. Are materials that let electrons pass through them. Now, explanation for it, or what do you mean by that it let electrons to pass through them? As we explained and we said, all matters are made up of atoms. These atoms, it contains electrons. So, some materials have electrons. These electrons are so loosely held to their atoms. Okay, what's that mean? It means they can move or they can pass freely. This kind of electrons, we call them free electrons. Okay. So, materials that it have free electrons, they are a good conductors. Example, we have metal. Metals are good conductors for heat and electricity. Insulators. Insulators, it's opposite to conductors, okay? Insulators are materials that hardly conduct at all. Okay, their electrons are tightly held to the atoms. Okay, and are not free to move. Okay, then example for insulators, it's like plastic, wood. Okay, all of these are examples of insulators. Then we have some materials, we call them semiconductors. What do you mean by the word semiconductors? It means it's between. It can conduct, or it's like we can consider it as conductors, and at the same time we can consider them as insulators. So how is that? So it depends on some factors. Okay, it's like there should be something that it will help it to conduct. For example, semiconductors, these are in between materials. They are poor conductors when cold, but much better conductors when warm. So here we have what? Material. Its conductivity depends on the temperature. If it's cold, it will not conduct. If it's warm or hot, it will be much better conductors. And if you will look at these three tables, you will have examples of conductors, insulators, and semiconductors. Okay, conductors, good conductors like metal, okay, especially silver, copper, aluminum, and poor conductors, water. Here, maybe you will say, but Mr. Water, it conducts electricity. Okay, here the point is what? The pure water, the water that doesn't contain any impurities. Okay, it's like salt. What do you mean by impurities here? It's like salt. Okay, the pure water, it's a bad conductor. It will not conduct electricity. Okay, and also human body, it's not good conductor. Semiconductors, silicon, germanium, insulator, PVC, polythene, perspex, glass, and so on. Questions. Say whether the following attract or repel. Before you start solving this question, you should know what do you mean by attract and what do you mean by repel. Okay, attract, it means bring it together. It has the ability to bring it together. Repel, it will separate, or it will let the objects be far from each other. Now, if you have two negative charges, will attract each other or repel? The answer, it will be repel, as it's shown here. Okay, two negative charge, what happened? They repel each other. Okay, C, a negative charge and positive charge, two different charges, so they will attract. B, okay, the arrangement here is not correct. Okay, two positive charges, although here they are it's like the charges are the same, so of course they will repel each other. Whenever you will have two charges the same, so they will repel each other. Whenever you will have two different charges, here they will attract each other. Now, question number 2. In an atom, what kind of charge is carried by proton, electron, and neutron? Proton, it has positive charge. Focus on the first letter, P. Positive, P, proton. The word proton and the word positive, both of them, they start with the letter P. So just this trick to memorize the word, the charge. Neutron, if you come to the word neutron, N, no charge. Neutron, no charge. While the electrons, it's negative. Okay. Question number 3. What makes copper a better electrical conductor than polythene? We said any material to be a good conductor, it should have free electrons. What do you mean by free electrons? It means the electrons are not tightly held in the atom. Question number 4. Why is it easy to charge polythene by rubbing but not copper? Here it's polythene. Polythene, it's example for insulator, as you can see here. Because it's example of insulator, so what will happen? Polythene is an insulator, so the charge, okay, don't move. Okay, so because the charge it's not moving, so we can charge it, okay, or it can carry a charge when you rub it with another substance. But if you come to copper, it's a good conductor. So what is happening, the charges are always flowing. Because they are always flowing, so what will happen here? So you cannot charge it. Okay. Another definition for static electricity, we will say it's the effect of stopped electricity. Okay. Now polythene, it's insulator. The electricity or the charge, when you will rub this material, what will happen? It will be stored in it, so it will not move. Because it will not move, so now it will carry a charge. But if you will come to the copper, if you will try to charge it, you cannot. Why? Because the electrons here are freely, they are moving freely, so you cannot store charge in it. Question number 5. Name one non-metal that is a good conductor? The answer. Most non-metals conduct charge poorly or not at all, although carbon is an exception. So the only exception of non-metals, it's what? It's carbon. Question number 6. It will be your task. In addition to this task, you need to solve the questions in the workbook. Again, don't forget to write your name when you will finish watching this video. I hope everything it was clear. If you still have any questions, concerns, please don't hesitate to text me. Thank you and have a good day.